this is the inlet flow Q1, and this is the pressure P, and this is outlet Q. And this question is talking about gas, so we are required to develop dynamic and steady state model. So here's the solution. We have 4 assumptions: ideal gas, isothermal, constant volume, constant molecular mass. The ideal gas equation shows that PV equal to nRT. The number of mole of the gas is equal to PV over RT, and is also equivalent to mass over molar mass. Moving on to mass balance. As mentioned here, N equal to MM, that is why here MN. So the MN over dt, M Q1 minus Q. Cancel off the M at left hand side and right hand side, you will get this equation. Lastly, cancel off the transferring V over RT to the right hand side. dP over dt is equal to RT over V, Q1 minus Q. At steady state, dP bar over dt is equal to RT over V, Q1 bar minus Q bar equal to 0. Hence, Q1 bar is equal to Q bar.
Okay, now we are going to the question number 2. For question number 2, the following are the information. As we know, constant hold up, volume at 46 meter cube. The volume flow rate will be 2.4 meter cube per minute. The concentration will at steady state will be 8.01 kilomole per meter cube. The temperature will be at 350 Kelvin, and we can neglect the variation in Q. Also, there are also new extra information for K naught, E, activation energy, and the gas constant. As you know, focusing on the K naught unit is per unit time. So we know that the reaction here is the first order. So the question asks us to develop linearized model of component balance equation in deviation variable form. First of all, we need to make the mass balance. For the mass balance, delta rho V over dt is equal to rho Qi minus rho Q. As we assume the density is constant, so we can factorize out the density. And also, as the volume is also constant, so we can assume that dV over dt is equal to 0. Hence, Qi is equal to Q bar, while V is equal to V bar. So we continue with the component balance. For the component balance, delta CAV over dt is equal to CAIQ minus CAQ minus RV. By using chain rule for the left hand side, we can change the left hand side into V dCA over dt plus CA dV over dt equal to CAIQ minus CAQ minus RV. Hence, because Qi is equal to Q, we can factorize out Q. Hence, the new equation will be V dCA over dt is equal to Q CAI minus CA minus K CAV. By dividing this equation with V, and also we know that K is first order reaction, we can the new equation will be dCA over dt equal to Q over V CAI minus CA minus K naught E to the exponential of negative E over RT CA. Hence, the steady state for this equation is dCA bar over dt is equal to Q bar over V CAI bar minus CA bar minus K exponential of negative E over RT CA bar. The next step is the linearization. So as you can see, the term that we need to linearize is the exponential of negative E over RT CA. Hence, when we linearize it with the Taylor first expansion, we will get this equation. Subtracting with the steady state and changing into deviation form, we will get the new equation, which is dCA dash over dt equal to Q bar over V bar CA dash minus CAI dash minus CA dash minus K naught E over RT bar squared exponential of negative E over RT bar CA bar T dash minus K naught E to the exponential of negative E over RT CA dash. Arranging the like term order in which we will bring all the CA dash over to the left hand side, we will get this equation. From this equation, we need to find the value of CA bar. to determine the value of C A bar, we need to use the steady state equation. Hence, from the steady state equation that we get earlier, this is the equation, and by putting all the value that we had found, we are be given C A bar is equal to 0.320567. Hence, we also need to find all the other terms such as Q bar over V bar, Q bar over V bar plus K naught exponential of negative E over RT, also K naught E over RT bar squared exponential of negative E over RT squared C A bar. So this is all the value needed. As with this value needed, we will put all this value into this equation. Hence, we will get the new equation, which is dCA dash over dt plus 1.3037 CA dash is equal to 0.05218 CAI dash minus 0.01395 T dash. Or, to make it more simplified, we can also put this equation in the form of 0.7671 dCA dash over dt plus CA dash is equal to 0.04 CAI dash minus 0.0101 T dash.
So for question number 3, it is given that the feed rate is 25,000 kg per hour with given density of 800 kg per meter cube, and we have heat capacity of 0.5, and then hold up in the tank is constant at 2080 kg of liquid, and we divide that with density and we'll get the volume of the tank. And then we have T1 30 degrees Celsius and temperature at steady state 90 degree and T equals 150 degrees Celsius at steam. So we were asked to derive mathematical model for this question. So moving on to distribution, we have few assumptions. So we have perfect mixing, which we can say that the exit temperature is equal to the temperature of the tank, with density of liquid system is constant, and last but not least, heat losses is negligible. Moving on to total mass balance, we have delta rho V over dt equals to Wi minus W, where W is the mass flow rate. Since density is constant, we are bringing density out and we get dV dt equals to Wi minus W, which becomes the first equation. There's no component, so we are neglecting component balance. Moving on to energy balance, this is the equation for energy balance. Du over dt equals to WIH I minus WH plus Q. So for liquid system, we can actually say that the internal energy is said in enthalpy dH over dt equals to WIHI minus WH plus Q. That's equation 2. And we know that H is mCp delta T, which is also equivalent to rho V Cp delta T. So substituting this equation into this equation, we'll get delta rho V Cp T minus T ref over dt equals to W 1 Cp T in minus T ref minus W Cp T out minus T ref plus Q. So we know that the density Cp and V value is constant, so therefore rho V Cp D is brought out, D T minus T ref over dt equals to W Cp T in minus T out plus Q. And then we have dt over dP equals to W over rho V T in minus T out plus Q over rho V Cp, because we are bringing this over to this side, meaning we are dividing all of this with rho V Cp. So we are going to eliminate rho V Cp here, and then we get the rho V here and rho V Cp over here. Green row. Yep. And then substituting the given values into each variables, we'll get this. So therefore, the final answer would be dt over dt equals to 12.02 T in minus T out plus 9.61 times 10 to the power of negative 4 cubed.